Hello everyone, my name is Li Yao and the title of my article is Study on Pixel Level Segmentation and Area Quantification of Highway Slope Cracks. I will explain from the four parts of research background, research approach, experimental analysis, and conclusion. Let's start with the background. China is a country with frequent geological hazards, and the serious hazards of highway slope is related to economic development, traffic, production, and the safety of people's life and property. The mountain area highway slope features is large number, steep slope. The surface of slope body is bare and leaky. The internal geology of slope body is complicated, and the problem of gap development and stability are more prominent. So what is the highway slope hazard? It explains like this. Due to the complex topographic and geological conditions of the highway slope, the mountain highway is faced with slope problems such as landslide and collapse in the construction and operation process, which affects the normal operation of the highway and causes the loss of life and property to the related personnel. The most common type of highway slope disaster are landslide and collapse. Landslide is mean local stability of the slope is damaged, and the action of external stress, the rock and soil mass slides along one and more fracture slithering faces as a whole. It generally has this characteristic, mostly slow, moving along a fixed surface or band, usually keeping the original relatively intact. The horizontal displacement is greater than the vertical displacement. The collapse is mean, the phenomenon that the whole rock mass and the soil block on a steep slope slid down to the slope and the action of gravity and other external forces. It generally has this characteristic. It happens voluntarily and faster. There is so fixed surface and band, and the collapsed body is complicated destroyed. The vertical displacement is greater than the horizontal displacement. From the movement characteristic of the collapse and landslide, it can be seen that cracks are the early symptoms of most slope disaster, and the increased expansion and evolution of cracks are the direct reflection of slope instability. Therefore, capturing the change of cracks can be used as an important reference for real-time monitoring of slope condition. 2. Research approach. Highway slope is generally in the outskirts of Burren Mountain. Slope image of have some shadow, strong light, dark night, which will cause a loud noise in the crack detection of highway slope, affecting the effect of crack detection of highway slope. The existence of noise will lead to the characteristic of the highway slope. Crack detection is not obvious, which will affect the calculation of the crack area. So it is necessary to pre-process the highway slope crack image. That is, image grayscale processing, image equalization processing. The grayscale of the image is to change the color image of the RGB3 channel data into the grayscale image of the single channel data. The grayscale processing of the image can make the image containing only brightness information, without color information, which is convenient for further processing of the image. The image grayscale convention formula is as follows. Image equalization is used to enhance the image. After image equalization correction, the grace distance of the image can be widened. The grace distribution can be uniform, so as to increase the contrast, make the image detail clear, and achieve the purpose of enhancement. The equalization image is shown in feature, and it will see that the image becomes clear and clear. We can see from the picture of image equalization process. The main purpose of correct image segmentation is to facilitate further image analysis and processing. The crack of heavy slope has two characteristics of crisscross direction and difficult to locate and identify. Therefore, it is necessary to design the algorithm with high identification accuracy and a correct identification model that is easy to deploy and apply. At present, image segmentation methods are mainly divided into traditional methods and deep learning-based segmentation methods. With the continuous optimization and improvement of deep learning algorithm, image segmentation based on deep learning is applied more and more, which has the advantage of obvious feature extraction and high accuracy. In view of the characteristic of quark and the development of deep learning technology, an image segmentation network, FSNet, based on deep learning is designed in this paper to achieve the segmentation of quark image. The image segmentation framework is featured. The result of FSNet network segmentation is relatively agile binary image, which represents the quark and black represents the background. The number of which pixels in the image is counted by digital image processing technology to calculate the pixel area of the quark automatically. The specific process is as follows. Image processing first combines operation of morphological correction and expansion is used to eliminate the noise, such as isolated points in the output binary image, and then the discontinuous quark fragment, and processed through the connected domain operation, and then the threshold of the connected domain area is set to determine the number of continuous and complete quark in the image. And the first is calculation the quark pixel area. The pixel statistical method is used to calculate the convergence area of quarks in the image. The calculation of the actual quark area is an important part of slope disaster monitoring, but it is difficult to measure the actual quark area from the image. The chessboard mapping method is proposed in this paper. The chessboard is used as a calibration plate, and the actual length and width of the chessboard are known according to the principle of keyhole image, and the correct length is measured by length radio and no length of the reference object. First, use a professional camera to capturing altering black and white chessboard, and record the height distance camera evolution when shooting, as shown in feature. The chessboard is 1 by 1. Binary processing was carried out on the captured chessboard image, and the combined operation of morphology, touching, and expansion was used to eliminate the noise, such as isolated points in the output binary image, and then the discontinuous quark fragment were switched to through the connected domain operation. If quarks of the pixel fall with one of the chessboard grid, non-fractal pixel area, chessboard pixel area, and the actual area of chessboard according to the law of the map to the actual area and of the quark. Please note that the first paragraph of the section and all subsection is not indented. The first paragraph that follows a table feature a quotation does not have an addend at the The above image processing method was used to obtain the crack area of the highway slope, and the above image processing method was verified by taking the highway crack as an example. A certain section of pavement with cracks was selected. The experimental data was 300 highway crack images collected by professional cameras, and the image pixel size was 3,000 and 4,000. 10 images with crack were selected to calculate the pixel area of cracks. At the same time, the crack area of the road surface was mirrored by the crack area of observation instrument and compared with the calculated actual crack area. Observation area refers to the area between the mirrored value x and the true value x, which is the difference between the mirrored value and the true value. Relative error refers to the ratio between the absolute error and the true value, which can affect the reliability of the measurement. The calculation formulation of absolute error is as follows. The comparison results are shown in table. It can be seen from the table that the recognition accuracy of this image is detection measured is high. And the fall is conclusion. According to the characteristic of slope cracks, this paper realized the pixel level detection of slope cracks based on deep learning and digital image processing technology, showing that deep learning has great advantage in crack detection. At the same time, the chessboard mapping method is proposed and combined with the simulated dataset of highway crack. The simulation screen is constructed and the comparative experimental is set, and the actual area of slope crack is calculated. The result shows that the method is feasible for the detection of crack area. Although board mapping method can well solve the problem of actual slope crack area computation, but there is still a homemade checkboard recognition accuracy. The next step we continue to improve the method for calculating the actual highway slope cracks, to improve the detection of highway slope fracture area as a result, improve the reliability and accuracy of the algorithm. So, above is my report. Please criticize and correct. Thank you.